Hello friends, welcome in a lecture of Dynamics of Machinery subject. Myself, Mitesh Patel. I am a assistant professor in a mechanical department at a Dr. Subhas Technical Campus, Junagadh. Today's our lecture topic is a flywheel. So in this lecture, we discuss about the flywheel, how it's work, what is the purpose to use the flywheel, and how its energy store and fluctuation of energies and examples related to flywheel. It's also solved in this lecture. So let's start the lecture. First we see the what is the flywheel and how it is used. Flywheel used in machine serves as a reservoir. What kind of reservoir? A reservoir of energy, which store the energy during the period when supply of energy is more than the requirement, and release it during the period when requirement of energy is more than the supply. Okay, so it's one kind of reservoir of energy. It store the energy when higher amount of energy is generated or more than the requirement. Then if the energy is generated more than the requirement, then it store and release the energy when the requirement of energy is more than the supply. So it's one kind of reservoir of energy. In case of steam engine, internal combustion engine, reciprocating compressor and pumps, the energy is developed during only one stroke, and engine is run for whole the cycle on the energy produced during the only one stroke. So the excess energy developed during the power stroke is absorbed by the flywheel and released into the crankshaft during the other strokes, in which no energy is developed. Thus the rotating crankshaft is rotating at a uniform speed. So flywheel is done. What done? It's absorb the energy during the one stroke, one or power stroke, when the energy is generated, and release the energy at the another stroke of cycle where the energy is not developed. So the crankshaft is rotated at a uniform speed. Okay. Hence the flywheel does not maintain the constant speed. It simply reduces the fluctuation of speed. Flywheel is not used for the constant speed or maintain to constant speed, but it's reduce the fluctuation of speed. So flywheel is used to reduce the fluctuation of speed. Okay, so flywheel is basically used for the fluctuation of speed is reduced. In the other word, the flywheel control the speed variations caused by the fluctuation of engine turning moment during each cycle of operations. Means the flywheel is controls the speed variation caused by the fluctuation of engine turning moment during the each cycle of operation. In each cycle we know that only one power stroke is there and another stroke, so not energy is developed. Total energy is developed in one stroke. So higher amount of energy generated in one stroke, but in another stroke no one energy is generated. No energy is generated. So this fluctuation is reduced by the flywheel. Okay, I hope you understand the why the flywheel is used and what is the work of flywheel. Now next term is the coefficient of fluctuation of speed. Fluctuation of speed coefficient. So for that we see the what is the maximum fluctuation of speed. The maximum fluctuation of speed is the difference between the maximum and minimum speed during the cycle. So maximum fluctuation of speed we can get through the difference of maximum and minimum speed. Okay, so n1 minus s2 is called, n1 is the maximum and n2 is the minimum. So both difference we can, from both of difference we can get the maximum fluctuation of speed. Okay, now we have to find out the coefficient of fluctuation of speed. So it is the ratio of maximum fluctuation of speed to the mean speed. Okay, so maximum fluctuation of speed is the n1 minus s2, where n1 is the maximum and n2 is the minimum, and the mean speed. Okay, it is the ratio of maximum fluctuation of speed to mean speed. Coefficient fluctuation of speed is the ratio of maximum fluctuation of speed to the mean speed. And what is the mean speed? It is the average of maximum to minimum speed, or maximum minimum speed average, n1 plus n2 upon 2. So now coefficient of fluctuation of speed is defined by Cs. Okay, and according to definition or ratio is the maximum fluctuation of speed n1 minus s2, mean speed, and now put the value of mean speed. So n1 plus n2 upon 2, and 2 is goes to in numerator. Okay, now this n is, this equation is converted into the omega or angular speed equation. So n is converted into the omega, so nothing change, we know that. So instead of n we can write the omega 1 minus omega 2 upon omega, and similarly mean angular speed is equal to omega 1 plus omega 2 by 2, and 2 goes to the numerator. And similarly we also write the equation in form of linear velocity v1 minus v2 upon v, and similarly 2 into v1 minus v2 upon v1 plus v2. Okay, the coefficient of fluctuation of speed is limiting factor in the design of flywheel. So coefficient of fluctuation of speed is the very important factor to design the flywheel. It varies depending upon the nature of service to which the flywheel is employed. So the value of the coefficient of fluctuation is varies, and it's selected as per the where the flywheel is used. Okay, as per the situation where the flywheel is used. Okay, now the reciprocal of the coefficient of fluctuation of speed is known as the coefficient of steadiness. So coefficient of steadiness is nothing but the reciprocal of coefficient of fluctuation of speed. Coefficient of steadiness is denoted by m, is nothing but the reciprocal of fluctuation of coefficient of fluctuation of speed, Cs. Okay, or the equation is invert to the Cs. Okay, now next is the energy stored in a flywheel. Okay, so what kind of energy is stored into the flywheel? It's we very well know that the kinetic energy is stored into the flywheel. So here we consider the kinetic energy. So let's elaborate the whole things. So flywheel is shown in figure. The figure is shown of flywheel. The first is the rim, and this is this for arm, and this is the hub for which the flywheel is mounted to the shaft. Okay, and the capital R is the radius of arm. Okay, we have discussed in that when the flywheel absorbs the energy, its speed its speed increases, and when it's give up energy, its speed decreases. Okay. According to discussion, if energy is absorbed, slightly speed is increased of the flywheel, and if the release the energy, the flywheel, then speed of the flywheel is decreases. Okay. So small m is the mass of flywheel, k is the radius of gyration of flywheel in meter. So I is the mass moment of inertia of the flywheel, abouts is the rotational axis. Okay. And it's a mk square. N1, N2 is the maximum and minimum speed during the cycle in RPM, and omega 1 omega 2 in radian per second. Okay, maximum and minimum angular speed. Okay. Now n is the mean speed during the cycle in form of RPM. So n1 plus n2 upon 2, and here omega is the mean angular speed during the cycle in radian upon second. So omega 1 plus omega 2 upon 2. Okay. Now CS is equal to, we know that maximum fluctuation of energy omega 1 minus omega 2 or n1 minus n2 upon mean speed angular or RPM. Okay. N or omega. Now we know that the main kinetic energy of the flywheel is defined by, of a rotating body, kinetic energy of flywheel is 1 half I omega square, and we know that the kinetic energy of rotating body is defined by 1 half I omega square. So flywheel is rotated, so flywheel kinetic energy is represented by E is equal to 1 half I omega square. E is the energy, kinetic energy. Now as the speed of the flywheel change from omega 1 to omega 2, the maximum fluctuation of energy delta E is the maximum fluctuation of energy. So it is the difference between omega 1 minus omega 2. So maximum kinetic energy minus minimum kinetic energy. Okay. Okay. Now put the maximum kinetic energy here. I omega is the omega 1, and here the minimum kinetic energy, the omega is the omega 2. So this is the difference between the maximum kinetic energy and minimum kinetic energy, which give the maximum fluctuation of energy, okay, during the cycle. So this is the difference as shown in slide, and the 1 half is taken out and I is taken out from the bracket, and omega 1 square minus omega 2 square. Okay. Now the omega 1 square minus omega 2 square, it's simplified into the 2 bracket. We know that omega 1 plus omega 2 and omega 1 minus omega 2, and we know that omega 1 plus omega 2 upon 2 is a omega mean angular speed, omega, okay, as shown in bracket. So put the value of omega instead of omega 1 plus omega 2 upon 2. This 2 is taken into down of omega 1 plus omega 2. So it's gone. So I into omega into, sorry, in bracket omega 1 minus omega 2. Now omega 1 minus omega 2 upon mean angular velocity omega is the coefficient of fluctuation of speed. We know that. So here omega is multiplied and divided. So here is the omega square, and here in omega. So this is a coefficient of fluctuation of speed. So we can write the CS, coefficient of fluctuation of speed, and I omega square. Okay, and if we write the value of I is the mk square omega square CS square. This is equation is the final maximum fluctuation energy equation for a flywheel. And in other term, we can say that 1 of I omega square is equal to E. Is the kinetic energy of flywheel. Okay, so this is also equation of maximum fluctuation of energy of flywheel. Okay, 2E CS. Now the note is taken. The radius of gyration may be taken equal to the mean radius of rim. Okay, because the thickness of rim is very small compared to the diameter of rim, therefore it's neglected. So K is equal to R is considered. So that's why here mk square. So K, write the R instead of K. So the equation become mr square omega square CS. This is the final equation. Okay, and R omega is equal to linear velocity V. Okay, so this is the final equation of fluctuation of energy of flywheel. Okay, clear? And now the considering the case omega is equal to 2 pi n upon 60. Therefore the equation of delta E, fluctuation of maximum fluctuation of energy, is the I omega into omega 1 minus omega 2. So put the value of omega or equation of omega 2 pi n upon 60, 2 pi n1 upon 60, 2 pi n2 upon 60. If we commonly take the 2 pi upon 60, commonly take the 2 pi upon 60 from bracket, and it's multiplied with the 2 pi upon 60, so 4 pi square upon 3600, and I into n in bracket n1 minus n2. Okay, now the 4 is cancelled with the 9 into 4, so 4 is cancelled. So pi square upon 900 into I into n, and would the write the value of I is the mk square, and here we know that n1 minus n2 upon n, so here is the n square is considered, so here n is there, and this is the CS, so mk square n square into CS into pi square upon 900. This is the equation of delta E. This is the equation too easy for the calculation. If we directly use this, then calculation is little bit easy. Okay, in a numericals. So we directly use this equation for a numericals of fluctuation of energy for a flywheel. Okay, now see the examples related to flywheel. Okay, the mass of flywheel of an engine is 6.5 tons. Okay, the mass of engine is given, so in a kg we know that 1000 multiply, so 65,000 kg of machine for flywheel weight is a 6500 kg. Okay, and the radius of gyration is a 1.8 meter, so K is equal to 1.8 meters. Now it is found that from the turning moment diagram that the fluctuation of energy is 56 kilonewton into meter. Okay, the fluctuation of energy delta E is equal to 56 kilonewton into meter. So convert into the Newton. So into multiply with the 10 raised to 3. Okay. Now, if the mean speed of the engine is 120 rpm, find the maximum and minimum speeds. Okay. So we have a mean speed n in form of rpm. So we can write is equal to n is equal to 120 rpm. Okay. So we have to find out the maximum and minimum speed n2 and n1. N1 is the maximum and n2 is the minimum. Okay. So now we have the equation of energy, fluctuation of energy, for a flywheel, and we have an energy, okay, and fluctuation of energy. We have a value of mean speed, we have a value of k, and we have a value of m. So we can get the value for a n1 minus n2. So put this equation, take this equation and put the value of all element in this equation of known, and finally we get the value n1 minus n2 is equal to 2 rpm. Okay, so difference of n1 minus n2 is equal to 2 rpm. And now we know that what is the mean speed and how do we get n1 plus n2 upon 2, average of maximum and minimum speed. So according to that, put the value of n and we get the value of n1 plus n2, and we have a two equation 1 and equation 2. n1 minus n2 is equal to 2 rpm, this is the one equation, and n1 plus n2 equal to 240 rpm is equal to 240 rpm, and this is the equation 2. So from both equation we can find out the value of n1 and n2, and we solve the example. N1 value is the 121 rpm and n2 have a 119 rpm. Okay, I hope you understand how to solve the example. Let's the other example. The flywheel of steam engine has a radius of gyration of 1 meter. Okay, the flywheel of steam engine has a radius of gyration 1 meter. So k is equal to 1 meter and mass 2500 kg. The flywheel weight, mass is a 2500 kg. Okay, the starting torque of steam engine is 1500 Newton into meter. The starting torque T is given 1500 Newton into meter, and maybe assume constant. The torque is assumed to be the constant. So torque is a constant 1500 Newton into meter throughout the cycle. The angular acceleration of the flywheel. What is the determine? First we have to determine the angular acceleration of flywheel alpha, and second thing to determine is the kinetic energy of flywheel after 10 seconds from the start. Okay, so we have to find out the kinetic energy of flywheel after the 10 seconds from the start. Okay, so for that we know that the kinetic energy is defined by rotating body. Kinetic energy is defined by 1/2 I omega square. So we have to find out the omega for a 10 second, and we know that the V2 is equal to V1 plus AT. So this equation is applied for the angular speed also. So omega 2 is equal to omega 1, and angular acceleration is defined by alpha t. Okay, so if we have a value of alpha, and we know that at a rest condition, initial condition, omega 1 is a 0. So if we find out the value of omega, then we find out the value of omega at a 10 second. If we put the value of t as a 10 second, then we find out the omega value as at a 10 second. Okay. So first we have to find out the value of alpha, and we know that how to find out the alpha from the torque equation. We know that T is equal to I alpha, and I is a mass moment of inertia. So firstly we find out the mass moment of inertia. I is equal to mk square, and here mass is given and radius of gyration is also given. So we easily find out the mass moment of inertia. It's a 2500 kg into meter square. Okay, mass moment of inertia. And here torque is equal to I alpha. So torque value is also directly given into the data, and we already find out the mass moment of inertia value. So we get the value of alpha. So finally we get the value of alpha is a 0.6 radian per second square. Okay. Now according to that equation, omega 2 is equal to omega 1 plus alpha t. But the initial condition, at a rest condition, initial condition is considered as a flywheel is a rest. So omega 1 is equal to 0. So omega 1 is a 0, and we already find out the value of alpha is a 0.6. And t, at a 10 second we have to find out the value of omega. So t value is a 10 second is considered, and finally we get the value of omega 2 is the 6 radian per second. Okay, and this is the omega 2. And now this omega is at a 10 second, the angular speed of flywheel at a 10 second. And from there you can find out the kinetic energy of flywheel with the help of angular speed. At a 10 second, angular speed is a 6 radian per second. So use that angular speed for a kinetic energy, 1 half I omega square, and omega is omega 2 square. So omega 2 value is the 6 is considered, and finally we got the kinetic energy of flywheel at a 10 second is a 45,000 Newton into meter, or 45 kilonewton into meter. Okay. So this way we solve the examples of flywheel. I hope you very well understand how to solve and how to derive the equations of fluctuation of energies, and how to solve the examples related to fluctuation of energies and torque and fluctuation of speed. Okay. Thank you for listening a video. Thanks.